Replacing existing electrical panels is a common task, but it raises important questions about grounding, especially concerning compliance with the National Electrical Code, or NEC. This narration addresses the specific scenario of replacing Federal Pacific Electric, or FP, panels in an 8-unit apartment building, focusing on the grounding electrode system, or GEC, considerations. Firstly, let's address replacing the panels without affecting the GEC. The key is to avoid making any changes to the existing GEC connections. By doing so, you can replace the panels without triggering a requirement to upgrade the entire grounding system to current NEC standards. Installing grounding lock nuts and the 1-inch electrical metallic tubing, or IMT, feeder conduits is crucial. This creates a continuous equipment grounding conductor, or EG, path from the panels back to the GEC at the water pipe. This EGC path is essential for safety, providing a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers. Secondly, let's address compliance with current NEC standards. If you make any alterations to the GEC, you are obligated to comply with the latest NEC requirements. However, if you only replace the panels and maintain the existing GEC connections, an upgrade to the water pipe GEC or the addition of a supplemental GEC like a ground rod is not necessary. This is because you are maintaining the existing grounding system's integrity without introducing any new potential issues. The reason for asking these questions often stems from the panel's location. If the panels are in a common area, such as a dog house, it may resemble a service equipment location. Service equipment has stricter grounding requirements. However, if the panels are fed from overhead meters and contain a limited number of circuit breakers, they might not be classified as service equipment under the NEC. Specifically, NEC Section 230.9T, which addresses service overcurrent protection, is relevant here. In this scenario, where the panels have only two 20-amp circuit breakers, they are likely not considered service equipment. Therefore, upgrading the water pipe GEC or adding a supplemental GEC is not mandated. Grounding is a critical aspect of electrical safety, and the NEC provides detailed guidelines to ensure effective grounding systems. The purpose of grounding is to minimize the risk of electrical shock and to provide a path for fault currents to safely return to the source, allowing overcurrent protective devices to trip and clear the fault. The GEC connects the service equipment to the grounding electrode system, which typically includes a combination of electrodes such as metal water pipes, ground rods, and concrete encased electrodes, also known as UFRs. The size and type of GEC are determined by NEC Table 250.66 based on the size of the service entrance conductors. The grounding electrode system must comply with NEC Section 250.50, which requires that all available electrodes be bonded together to form a single grounding system. This ensures that all parts of the system are at the same potential, minimizing the risk of voltage differences that could cause shock hazards. In the case of a metal water pipe used as a grounding electrode, the NEC requires that it be supplemented by an additional electrode, such as a ground rod or concrete encased electrode. This is to ensure that the grounding system remains effective even if the water pipe is disconnected or becomes non-conductive. The supplemental electrode must comply with NEC sections 250.52a, 5 and 250.53a. Installing grounding lock nuts in the EMT conduits provides a reliable EGC path. The EGC is crucial for carrying fault current back to the source. When a fault occurs, such as a short circuit between a hot conductor and the metal enclosure of equipment, the EGC provides a low impedance path for the fault current. This high fault current causes the overcurrent protective device, such as a circuit breaker or fuse, to trip, quickly disconnecting the circuit and preventing a dangerous buildup of voltage on the equipment enclosure. The size of the EGC is determined by NEC Section 250.122, based on the size of the overcurrent protective device. For example, a 20-amp circuit requires a 12 American wire gauge or AUG copper EGC. The EGC must be installed in the same raceway or cable as the circuit conductors. The NEC also addresses the bonding of metal parts such as enclosures, raceways, and equipment frames to the EGC. Bonding ensures that all metal parts are at the same potential, minimizing the risk of voltage differences that could cause shock hazards. NEC Section 250.92 specifies the requirements for bonding service equipment, while NEC Section 250.96 covers the bonding of other metal parts. In older installations, it is common to find that the grounding system does not fully comply with current NEC requirements. For example, the GEC may be undersized or the supplemental electrode may be missing. In these cases, it is important to carefully evaluate the existing grounding system and determine what upgrades are necessary to bring it into compliance with the current code. The decision to upgrade the grounding system will depend on the scope of the work being performed, the condition of the existing system, and the budget available for the project. In some cases, it may be possible to make incremental improvements to the grounding system over time as opportunities arise. However, in other cases, a complete overhaul of the grounding system may be necessary to ensure safety and compliance. When performing electrical work, it is important to follow all applicable safety precautions. Always de-energize circuits before working on them and use appropriate personal protective equipment, or PPE, such as rubber gloves and safety glasses. Test circuits to verify that they are de-energized before working on them. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Now, let's consider the specific details provided. The existing service is overhead, and the GC is connected to a local water pipe, specifically a hose bib, which is more than 75 feet from the water service entrance. This distance is a concern because the longer GC increases impedance, reducing the effectiveness of the grounding system. The NEC generally requires the GC connection to be made within 5 feet of the water service entrance. However, since the proposed work does not involve modifying the existing GC, it is permissible to maintain the existing connection. If the GC were to be relocated or replaced, it would need to comply with the current NEC requirements, including the 5-foot rule. The fact that there is no visible ground rod is also a concern. As mentioned earlier, a metal water pipe electrode must be supplemented by an additional electrode. A ground rod is a common choice for a supplemental electrode. The NEC requires that ground rods be at least 8 feet long and driven into the ground to a depth of at least 8 feet. If rock bottom is encountered, the ground rod can be buried horizontally in a trench at least 30 inches deep. Again, since the proposed work does not involve adding a new grounding electrode, it is permissible to maintain the existing system without a ground rod. However, it is important to note that the absence of a supplemental electrode reduces the effectiveness of the grounding system. The existing wiring method is EMT from the meter to the panels and flexible metal conduit, or FMC, to the units. The use of EMT is beneficial because it provides a continuous metallic path for the EGC. The grounding lock nuts on the EMT connectors will further enhance the conductivity of the EGC path. However, the use of FMC as the GEC to the units is not ideal. FMC is not recognized as an equipment grounding conductor unless it meets specific requirements outlined in NEC Section 250.118. If the FMC does not meet these requirements, a separate EGC, such as a green insulated wire, should be installed within the FMC. In the proposed scope of work, the existing mechanical bond for the EGC will be replaced with grounding lock nuts and the 1-inch EMT feeder conduits. This is a good practice because it improves the reliability of the EGC path. The 1/2-inch FMC is being used as the GEC to the units, which, as mentioned earlier, may not be compliant with the NEC. In summary, the proposed work of replacing the FPE panels with square D panels can be performed without triggering a requirement to upgrade the entire grounding system, provided that no changes are made to the existing GEC connections. The installation of grounding lock nuts on the EMT conduits will improve the reliability of the EGC path. However, it is important to be aware of the limitations of the existing grounding system, including the long GEC to the water pipe and the absence of a supplemental electrode. If budget permits, it would be beneficial to upgrade the grounding system to fully comply with the current NEC requirements. This would involve relocating the GEC connection to within 5 feet of the water service entrance, installing a supplemental electrode, and ensuring that the FMC used as the GEC to the units meets the requirements of NEC section 250.118. Remember to always consult with a qualified electrician and follow all applicable electrical codes and safety regulations when performing electrical work.